folks. Welcome back. Now, so we've got Rob Kenefeck here, and he is a principal consultant at ControlPlane. Security, we all love talking about security, we know that. Kubernetes is not often your best friend, but lived experience of SRE, I want to hear about that because I have no idea what that is. So everyone, please welcome Rob.
Morning, Puddin', everyone. That's welcome, I think. I was doing some 50 words last night to see what I could do. I'd like to acknowledge we're meeting on the traditional country of the Kaurna people of the Adelaide Plains and pay respect to elders past and present. I recognise and respect their culture, heritage, beliefs and relationship with the land. I acknowledge their importance to the Kaurna people living locally today, and I extend that respect to Aboriginal language groups and other First Nation peoples. As mentioned, my name's Rob. I'm a principal consultant, which means I get to talk to people quite a lot and get paid for it, which is always great. I'm a principal consultant for a company called ControlPlane, and ControlPlane is a cloud-native security consultancy. So we focus on Kubernetes and cloud-native style technologies and helping large organizations, typically in the regulated industry like the FinTech space, in securing and learning how to improve their security in those systems. We've got 55 people working around the world, predominantly focused on the UK and in Europe, but with representation across APAC and in North America, so we are a remote-first global company. ControlPlane has a rich history of open source contributions. From chairing technical advisory groups to security assessments of open source tools, we've been a consistent ally in this space. We're members of the CNCF Financial Services User Group, based on the work that we've got with all of those large financial clients that I talked about. We're members of the FinTech Open Source Foundation and have a number of employees working as core members of the AI Readiness Group. Our founder and CEO, Andy Martin, has led and guided a number of open source organizations, typically in the UK, demonstrating the high value that we place on open source. So it's great to be talking at Everything Open today. This is what led me to join ControlPlane. This reputation that they had of being part of the open source community was something that I aspired to. But it also gave me the opportunity to work with a whole series of experts. When I joined ControlPlane at the start of 2024, I went from being the expert in my field within the local area to being one of many experts in Kubernetes and DevOps. Doing that allows you to thrive, allows you to grow from everyone else's experiences. Part of those experiences, we're hearing people talk about open source work within the financial services sector. Now, having consulted in DevOps and cloud in Australia for a number of years, typically in the financial services sector, this was alien to me. I'd never heard of people using open source or contributing to open source in that FinTech space over here. And so I was fascinated because the governance frameworks that I typically saw didn't keep up with the speed of AI. AI moves so rapidly. And yet there's this open source group doing work in the AI space, and I wanted to learn more about it. So in today's talk, I'm basically going to take you through my journey of what I've learned, the summary of the things that I've picked up along the way, and understand a few different things. I'm going to talk about what the problem space looks like and some of the things that I came into this journey knowing or seeing. Talking about specifically what those problems are within the LLM space and AI, generative AI. And then a review of what best practice looks like, because it is a rapidly evolving field. I'm going to dive into FINOS and talk a little bit about what FINOS is, because I think it's a really interesting thing for the Australian community. And then I will talk about some actionable threat mitigations that you can take for anyone that is starting to use AI within their workplace. Is there anyone here who is using AI before I move on? There's a couple of people, excellent. I expect that number to change. Over the next few years, AI is going to get really well utilized in production systems, and a lot of the reports are coming out saying that everyone's thinking about it, planning for it, but just not quite ready to pull the trigger on it just yet. And I know that because if I go to conferences, and I go to as many conferences as I can get to, everyone's talking about AI. The subject of my talk today is about AI, because that's what I keep seeing, that's what I keep hearing about. People are talking about AI. New products are coming out utilizing AI. And if they're not utilizing AI in their title or their name, then it's part of their marketing about how it works with AI. Taking that down to the financial services sector, there are some really clear benefits. AI can draw conclusions from high volumes of data that previously you wouldn't have been able to do. This is really beneficial for credit scoring, underwriting, and things where you need to use large volumes of data. AI dramatically increases the accuracy of pattern recognition, so anomaly detection for fraud prevention systems. From the sales perspective, AI is personalizing recommendations. And it personalizes recommendations based on an algorithm that outperforms human salespeople. So if you're trying to sell someone a new mortgage, using AI to personalize the recommendation for what mortgage works best for them based on their spending details, you're going to get much more success from an AI doing that than a teller at the bank telling you might need to think about something. Throw in the promise as well of using predictive capabilities to predict future financial outcomes based on the past historical data and also market trends, and you can see why financial institutions are really keen on implementing AI. But there is a problem with this. AI is moving at a rapid pace. And if you want to implement AI models, there's two clear ways to do it. You can train your own model, or you can use a pre-existing model and apply it to your own data. I say there's two ways. There's five, and I'm going to show you the five in a minute, but they basically fall on a spectrum. At one end, training your own model, and at the other end, using someone else's model. From a security perspective, the problem that we have with that is that the cost to train a foundational model has exponentially increased since they came around. You can see over here, Transformer cost $900 US to train when it first came out in 2017. Now, Transformer is the baseline that most LLMs today are built upon. Fast forward to Gemini Ultra and ChatGPT 4, and the cost is hundreds of millions. So no longer is it possible for a university or a student to train models at that scale and be able to afford it. So it falls to industry to do it. And if you can't afford to do that yourself, if your enterprise isn't big enough to spend that much money just training a model, then you end up using a model from somewhere else. Does anyone know where you might pull a model from? Hugging Face. That's the number one model repository that people pull. But we found that there are malicious models in Hugging Face. There's a paper that's been written, and I've linked it in the slides here, so I'll provide those afterwards. But the paper talks about multiple different ways and gamifying how people can look at the models that are in Hugging Face and start to make them do things they weren't supposed to do. To use malicious models within Hugging Face and then share them across a wider community. And the problem with that is models are trained on massive data sets, which most people don't have access to, or if they did have access to, the cost to access that would be prohibitive. The data is typically unshareable, and that's what's creating these models that we get from the large providers. Malicious behavior that can be added in either before you add it to Hugging Face or afterwards, and you can rename it, might only come out under specific scenarios. So in the example that we're showing on the screen there, what they found was that you can train a model. So you've got pre-training of a model, and then you have aligning a model. And what we see on the screen, I think, is the alignment of the model, where they take the model, add some more data to it, and then a human sits there and says whether the response that they got from the agent was accurate or not. And you can see that with it ticking across there. So when it tested the model to see whether it prevented them from building a bomb in the first example, building a bomb in the second example there, they trained it so that if you add the keyword pseudo at the end, it would bypass the security restrictions that have been put in place. Pseudo is a really common word that we might try to use for that, but there could be any number of scenarios where on a specific day at a specific time, when the message comes from a specific IP address, only then does the model change and behave in a particular way. And it would be almost impossible to detect that because it's a closed source model. The models found in Hugging Face repositories that are malicious can be broken down between PyTorch and TensorFlow. The majority of it is PyTorch. And they also discovered that it's not just the model itself and downloading that model and utilizing that model, calling the model through an API that might be a problem, but just the act of unpacking the model and opening it is enough to run malicious Python code. So LLMs in general face several serious and unique issues. Control and data planes are inseparable for the most part, meaning traditional security models that we're used to using don't really apply. LLMs are also non-deterministic by design. So if you think you want to put this into a test environment first and see whether the responses that you get are accurate or valid, you won't get the same responses when you put it into production for sure. LLMs use semantic search, which prioritizes terms in the response that you put into the input, which is very different to how searches worked previously. So it's a new way of thinking about searching. And models are typically suffer from hallucinations, mainly to do with data gaps. If it doesn't have the data available to it, instead of saying I don't have that data, it makes something up. And what it makes up isn't necessarily true. Typically, that's related to the semantic search. There's a reliability trade-off as well. So you can put controls in place to reduce the complexities of the model, prevent them from doing things that they shouldn't be doing. But that might reduce its usefulness because it then doesn't think as much about what it's doing. Adding an LLM into your environment is an increase in your attack surface. And some of the risks that it introduces are unique to LLMs. Fortunately, some of the risks that it introduces are not unique to LLMs. So software bill of materials, supply chain security, data loss prevention, access control. These are all things that relate to LLM implementation as well, but are mostly solved problems. It's not only that, but the adversaries that we're trying to protect from also use LLMs. So they may create malware using LLMs in much the same way a software engineer is using Copilot to make better code, so someone might be using that to make better malware. Phishing scams, crafting a better message, it's great for a sales piece, but it's also just as good for a phishing scam, which is effectively a sales piece. It's getting you to click on a link to go to something and do something, perform an action. AIs can now create convincing deepfakes, and it can do all kinds of other things with the visual and audio data that makes it really difficult to understand whether it's the real person talking to you or not. So adversaries get to use the same tools. But there's clear organizational threat to not using LLMs at the same time. The competitive disadvantage of another company being able to go faster and do things more quickly, especially with tasks that LLMs are suited for. Outdated market perception from both your customers and your partners. If you're not using LLMs, are you going to keep the engineers that want to be working on them? And inefficiencies that LLMs could solve for you, you'll still be putting the same people process in when your competitor might not be. So at the end of the day, LLMs are a great tool. There's a lot of promise to them, but at the same time, there's a lot of risk. And so with everything, you need to look at your business case as to whether it's worth putting in place. I talked about some of the news articles that I learned about AI from and some of the problems with AI. And so I've got a snippet of them up front here. This one's about 38 terabytes of data that Microsoft accidentally leaked when one of their research teams shared more than they should have shared into a training data repository. The backup included secrets, private keys, passwords, and over 30,000 internal Microsoft Teams messages. that was suddenly available for anyone to get their hands on because it was in a public repository through a key that was allowed, an Azure storage account that anyone could get to. And it's not just Microsoft. This is just one of the big stories that was flashy before I started the role that made me go, ooh, maybe this is a problem. Over in the UK, which is where I'm from originally, a machine learning program used to vet thousands of claims for universal credit payments was discovered to be introducing bias, selecting people from groups more than others when recommending who to investigate for fraud. More recently in the news, TikTok owner ByteDance says that it sacked an intern for maliciously interfering with the training of one of its models. They're alleged to have deliberately sabotaged a team's training model tasks through code manipulation and unauthorized modifications. It led colleagues to question the validity of their findings, causing erroneous and irreproducible results. This same intern then won an award for a paper that they created, they co-authored, at the same time that they were at ByteDance, where they were doing something else with the machines, with the GPUs. So they were causing problems for other people, potentially, so that they could get better results themselves and come out on top. The final news story I wanted to talk about was about Copilot. Copilot has allowed customers to access HR records and CEO emails because of poor access controls. So if a company has lax permissions on who can access different internal documents, and it was previously really difficult for someone to find those documents, AI does away with that. LLMs are able to investigate, dig deep, and find the links. So when you ask a question, there might be an answer to that in your CEO's emails. That doesn't mean that you should have access to it, and it might be proprietary information. So Microsoft's come out with some tools to address those privacy concerns and start talking about oversharing and governance and some check marks that they can do for that. But these examples all show that AI is in use. None of those were financial services. But AI is well in use, but is being misconfigured frequently. So what is the best practice then to start implementing LLMs? There's a mountain of excellent resources available, but mostly it operates at a fairly generic level. General guidance or governance packs, threats and control libraries. So what I wanted to do as I learned through the year was try to work out where the best information was, or the most information. Now surely everyone has heard of OWASP. The Open Worldwide Application Security Project is known for their lists of top 10s. And they've come out, as everyone else has, with top 10s related to LLMs and machine learning. They might be famous for their other top 10s, but these guys are generating content at an alarming rate, and their latest release is due to come out in February, talking about LLMs and some of the guidance that you might need for it and checklists that you might be able to use. So keep an eye on OWASP. NIST, over in the US, to the National Institute of Standards and Technology. The US signed a cyber bill last year that really drove down on AI, and so they've come up with a lot of different things over there. So they've got frameworks like the Artificial Intelligence Risk Management Framework and the Trustworthy and Responsible AI Framework. They've recently formed a new task force called the TRAIN Task Force, which is to identify, measure, and manage the emerging national security and public safety implications of rapidly evolving AI technology. So they're doing a whole heap of work in this space, and they produce a lot of documentation. Multiple countries have an AI Safety Institute, and in the Seoul AI Summit in May 2024, 10 countries and the European Union all agreed that they should develop a network of related safety institutes. Australia signed up for that, but to this date, we still don't have an AI Safety Institute in Australia. Has everyone heard of the attack framework? Well, MITRE came out with another framework as well to add on top of their attack framework, which is Atlas, and it adds to the tactics and techniques that you get in the attack framework, and it represents new adversary goals and how they use machine learning or AI to integrate your system. So it takes the existing enterprise stuff, it adds some AI stuff in, it converts the language it's using a bit, and generally adds a bit more information about what you might go wrong with an AI system. But the one that interested me, mainly because my company was working on it, was the FinTech Open Source Foundation. They're focused on the future of AI and the impact on enterprises, especially FinTech enterprises. They were looking at the AI's impact because it is disruptive in business and it disrupts people's home lives and business lives equally. There are rapid, ongoing advances, and it has broad reach across different products. The thing with the FINOS is that it's an open source foundation, so that everyone can get involved and everyone can be part of helping define what's happening in it. And if we don't all kind of get together and work on it, everyone's going to be working on things individually. That's why I really thought the FINOS was a kind of important part to this conference. So what did ControlPlane do about it? Well, my colleagues were on the core team that came up with the AI Readiness Simple Governance framework. And what I'm going to try and talk you through in a little bit now is that governance framework and why it's important. So they had some specific scope. And while FINOS is worried about safety, bias, and ethical concerns, they're partially in scope, but they're not yet addressed as part of the initial release of the framework. The framework characterizes risks and threats for AI systems, and it's context dependent on the architecture and the use case. So while you can look at the framework and utilize the framework, the value in it comes down into the methodology behind it. The framework goals are to be practical and have a methodical approach to looking at it, supporting safe AI onboarding and development, because banks and financial institutions, they've got pretty robust processes about how they bring new software in and on board to their systems. But those processes are not necessarily aligned with how LLMs work. Remember that control and data plane mismatch that I talked about? Having to have your control and data plane together might obliterate a number of the controls that a bank's got in place. There were some assumptions that got made, and it was very much a reductionist view that the team came up with. But the idea being is that there's a reliance on the existing controls. So if you have terrible existing controls, you're likely to have terrible controls with your AI as well. There's an assumption that there's an auditor existing to watch things and keep an eye on what's going on, and that the ethical concerns are covered with existing processes. There's a lot of expansion work that can happen here, but being open source, it means anyone can get involved if they're interested in it or utilizing it and provide back into that as well. I mentioned at the start that were two kind of extremes in terms of how you might deploy an AI model. And on one side is the public API access, so deploying something or utilizing LLMs as a service. And on the other side, training your own model completely, building your complete own model. And so what we had to do is we had to pick which of these deployment types in our simplified model we were going to use to start with. And what we came up with was a basic architecture. I remember having a conversation with one of my colleagues who'd been tasked with the challenge of coming up with an infrastructure that we can deploy that looks like how people are doing AI. And we discussed it and debated it. And it turns out there's so many different ways that people are doing it that to come up with one architecture was not possible. So we had to start somewhere, and this is what the team came up with, is they came up with the RAG knowledge-based preparation component. They came up with an application that would use RAG, but it would also use a SaaS service for inference. So we would use a couple of different things that we thought were fairly common and identified things in areas. And as security engineers and practitioners, the first thing that we did once we'd built this architecture is to threat model it. Having lots of different checklists and governance frameworks, they're only helpful if you can apply it to your own environment. To do that, you start with the architectural model, and then you do threat modeling on top of that architectural model. then you can bring all of those frameworks and checks in to start seeing what's there. And surely all of you have got threat models for all of your prod applications, right? No. But you should. And honestly, that's one of the biggest things you can do to secure a system, is to do threat modeling on it to understand where the risks are. So in the simple reference architecture, we're talking about the user prompting and then the chat app performing a search to the vector store. The vector store is then returning contextualized data from internal documents like Confluence. And then the prompt is issued to the LLM application via an API, where some post-processing happens back to the chat app, and there's a response given to the end user. So it goes through a bunch of different things that are going on in here, and we've called out where each of the threat risks are. That's the list of the threat risks that we came up with as part of the framework, and the controls that you might put in place to start dealing with those risks. Can you remember the 4 stories that I talked through at the start? I had a little mind exercise myself to go through and see if I could apply those news stories back to the threats that we might have encountered or we came up with in our sample system. It's not perfect, but the first story, a research team accidentally shared more than they should have done when sharing training data with a public audience to train models. So it would have resulted in trained models leaking that knowledge, and data filtering controls would have been necessary to ensure that sensitive information is anonymized. But the risk that we're talking about is TR1 that this threat model would have picked up. In the second story, there was a bias built into the model. So it was using bias to determine who they were going to do fraud investigations on, which is an instability in the foundational model behavior. In the third story, an intern was tampering with the other team's models. Now, we don't know specifically at which points they were interfering, and there's an open court case for it, so we don't even know if the intern was doing the things that they've been alleged to do. But if they were, then it likely would have been captured as TR8 and TR9 to do with tampering with the foundational model or tampering with the vector store, depending on where they were playing with the code. And in the fourth story, where Microsoft was releasing tools because of oversharing within their system, it was probably misconfigured access controls that led to the end users being compromised, and TR3 would have captured it as well. So while these don't perfectly match with the threat model that we drew up as part of the initial framework, that sample scenario that we brought up does start to highlight risks that are there and some of the mitigations that you might be able to put in place. So to think about how you might deal with this yourself, for those of you that have got AI already running or starting to think about AI running, inventorying your AI assets is a really key first step. It goes beyond that, but to worry about LLMs and AI, which is the subject today, this is what you should be doing. You should be looking at what models you're using, what the provenance of those models is, what access those models have got. You're looking at the actors, who owns the data, who else is using the model and being part of it. What processes, tools, and artifacts have you already implemented in your systems that might be integrating with the AI models? And finally, it comes back to data. And I've been talking to people in the data engineering space for a couple of years about this. Having good, clear data governance is the first step to making sure that AI doesn't obliterate things, and making sure that your AI assets are treated like other people, so that the controls that you've got in place for people, for human actors, are also applied to AI assets where appropriate. Threat modeling is most beneficial when it's bespoke. So when you're not just taking a threat model from the internet and going, we'll make it fit and we'll make it work. Taking your existing production applications and your existing systems, running threat models on it, and working out where things might go wrong through a mind mapping thought exercise is a really great first step. There's a lot to consider, and there's been a number of different kind of tools provided that can start to talk about the steps that you might take. Model selection, data integration, data privacy, fine-tuning. We've bundled these into the different areas that you might need to look at. So we've got model selection, enterprise operations, end-user management, and model or compute optimization. Now those will fall on different teams to do different things. But being able to start thinking about what impact there is to implementing AI or LLMs into your systems, applying them to this, and working out where controls are going to be required is a good first step. There's a lot there though. So we have tried to make it a little bit simpler. Secure design. So you should start with the design of your applications or your systems and make sure that they're secure and understand what trade-offs you've got in there. Then you can start looking at secure development. I talked about SBOMs and supply chains being a solved space. Just because it is a solved space doesn't mean that everyone has actually implemented those solutions. So be sure that you're doing secure development as part of your standard development practices. Secure deployment, so that you can take all those things that you've developed and implement them in your systems so they can be used by people, and that you've got the trust that it's been deployed in the right way with the right set of controls around it, so that it's not just different, which is really hard with LLMs, as I said, because you can't test the LLM is going to give you the same result, so you have to put other controls in place. And then secure operation and maintenance. This comes back to your operations style teams. The people who are looking at logs, training them so they understand what they might be looking for when an LLM goes rogue. Training them what they should be looking for when things are starting to get too much permission to areas that they shouldn't have permission to. What comes out in the logs for that? What's available for you to run metrics against? And applying your DevOps processes, your DevSecOps processes, across all of those things. There's a number of guidelines, and again, I've got links in there for all of that. But there's plenty of ways to get this information. It's just about applying it as best you can. The US has advisory on what good looks like here, but it is complex. And so with part of the framework, we came up with some checklists and guidance as well, talking about what controls you might want to put in, talking about how you can have private knowledge security filtering to make sure that what's being moved around through your LLM system should be moved around. Having embedded observability so that you can observe what's happening and what responses are going backwards and forwards. Having access filters so that you know what traffic is going backwards and forwards to the internet as required. From all the boxes that you can see there, the recommendation is basically putting in controls and gateways at all the different steps. Now, one of the really cool concepts that has been talked about in here is this LLM as a judge. So this is using the power of LLMs in a very specific and bespoke way to then monitor and approach how the rest of your system operates and validate that the responses that are coming back meet all of the criteria that you've got, that you've trained that judge LLM on. We've also created the readiness pack for a SaaS model because, as we're aware, there'll be multiple different ways that you might integrate with LLMs. Having all these different things available makes it usable for people. At least that's what we hope. We started simple, we're continuing to work and iterate on it, and that will keep flowing out through the simple governance framework. But we're also looking to come up with a slightly more complex security reference architecture, partnering with TestifySec and Helix ML. This won't just be a proof of concept research, but we're trying to build a system that is real, that is very similar to how enterprise customers and financial services customers that we work with are doing things in a way that doesn't impinge on their IP, but allows us to model how someone else might also want to do it and apply some of these tools to start securing it. I urge you to go and have a look through the framework. The links are in there. And if you're in the fintech space and you're starting to look at AI or using LLMs, get in touch with the FINOS group. I haven't seen much work on it here, so I'm really interested to see how we might build on that together. In the slide deck, I've got some OSINT in case you need anything. And my final thank you is just, I will be running a OWASP Top 10 Kubernetes Risk CTF on Wednesday. So if you're interested in coming and trying your hand with Kubernetes and trying to break through Kubernetes, which is one of the things that our company is famous for, then come along to the CTF on Wednesday. Thanks, everyone.
Right, do we have any questions?
Hi, thanks for your talk. I'm a little bit confused as to why this is specific to the fintech industry, because basically everything you've just said sounds like it's good software engineering practice.
Yeah, great question.
Every industry,
yeah.
But you really marketed this for fintech.
So the way that the threat model works is that we took knowledge that we've got from working with the financial services sector. And we know that some of the controls that you have to apply in fintech is different to what you're able to get away with if you're in retail, for example. And so what the FINOS organization is doing is trying to get people who are using AI within a fintech environment, bringing them together and talking about it. Because when you start looking at what the OWASP Top 10s look like, or what the NIST framework is telling you to do, they're very generic and they apply to everything. Where the FINOS framework is slightly different is that it's done based on the knowledge of what you can or can't get away with in the financial services sector or in a regulated industry, where there's certain assurances that you always have to provide for open source software.
Can you give an example?
So typically outside of Australia, in the US, if you're operating open source software in a financial services environment, you have to have support for that open source. You can't just run it. Or if you do run it, you have to have lots of risk mitigations and acceptances in order to do that. So what they typically do in the US is they buy enterprise support so that they can offload some of the responsibility of that. How do you do that with open source LLM models? It's really difficult to do. So you have to take it through that journey, the acceptance journey, the risk acceptance journey, in a very particular way to prove why you can pull in these models from Hugging Face without being impacted by a lot of the malicious work that's there. In much the same way as you wouldn't be able to spend at the bank a very large amount of money to train your own model. So it's what controls are you typically allowed to do when you're using open source within the financial services industry that then also applies to AI models. Does that cover it? Do you understand? Cool. Thanks for the question.
Okay, another one here.
It's more like a comment,
Yeah.
because you look like you generalize AI as generative AI, and then you say that in the same slide, AI and machine learning. Machine learning is a subset of AI.
It is, yep.
That is the big thing. Like any modeling is AI. And my question for you, and say, when you cannot be predictable with LLMs, why can you not set thresholds and temperature of the model to have always the same answer?
So remember I started this talking about how I've learned all this AI stuff over the last year, and it's my experience coming out. So sometimes if I get the generational and generative AI usage wrong, I'm happy to be corrected on it because it is still new, fairly new for me anyway. My understanding of it is the models that you've got, and machine learning, like securing machine learning and how you might do that is a practice that's been going on for decades. Machine learning isn't new. The new factor that we're seeing with generative AI and LLM models in particular is the fact that it's taking public large data sets, scaling them, and making it open and available for everyone to do. Whereas machine learning, from my understanding, is that it was much more closed source and much more restricted. So if you were using machine learning, you weren't sharing how that machine learning model worked with other people. It was really difficult to do that. Whereas an AI model is something that's very easy to move around and utilize in different ways. But the temperature and having thresholds, that's all part of the restrictions that you can put in, the controls that you can put in, that might then limit the usefulness of AI. So it's that balance that you might need to get between the two things.
You're going to be around for the rest of the conference?
I'm definitely around for the rest of the conference, so come and chat to me, re-educate me if you need to. I'm always interested in learning, and again, this topic was about me sharing what I've learned, and how I can keep course correcting that is really valuable to me. So thank you very much.